So we're going to go over properties of quadratics. And what we're trying to figure out is whether something is linear or quadratic between these equations here. Okay. So looking at the first one, it's kind of difficult to tell if something is quadratic or not. There's a specific exponent on a variable that will let us know for all four of these. Okay. So what we do is we look, and the easiest one to be able to tell is actually C. Do you know what type of graph this would create? If we were to graph this, would it create a straight line or would it create a parabola?
Straight line.
This one, C? Okay, well this one here has a exponent of 2. Okay, so anytime in an equation you have a variable to the power of 2, what that means is we're going to have a parabola in terms of the relationship. Okay, so because this one is a variable x to the exponent of 2, we have a parabola here. So, which brings us to D. This guy is technically to the power of 1. So the power of 1, if that's the highest exponent of any variable, that means we're going to have a linear relationship. Okay, so we'll put those down here quickly. So this is going to be quadratic, and this is going to be linear. Okay, so using that information, what about this one here? First of all, what's the power of the exponent? Yeah, it's just the power of 1. So what type of relationship do you think that'll be? Yeah, exactly. This would be linear.
But the top one has 2 x's.
Yeah, you're right. It has 2 x's. This one has, this variable is x to the power of 2, and this is x to the power of 1. We always look at the one of the highest exponent.
Right.
So which one is the highest exponent?
Squared.
Squared. So what type of relationship will we have?
Quadratic.
Exactly. Okay. So even if the other one is involved in it, it's still going to be a parabola when we draw it. So quadratic just means we have a parabola. Linear is a straight line. Quadratic, linear. Okay? Okay. So in order to fill this chart out, what we need to do is we need to take these x variables and plug them in for our t values, right? Because, oops, sorry, x represents time, not height. Have that backwards there. Time and height. So, actually looking at this, whenever you have an x variable of 0 and there's multiplication involved, you can essentially figure out that it is going to cause everything here to be 0. Okay? So essentially what happens is we plug in 0 for t. 0 squared is 0 times 4.9 is 0. 15 times 0 is 0. So you end up with 0 plus 0 plus 2. So your height ends up being 2 in this equation. Right? So that's your starting point. On your second one, we're actually going to plug it in here. So height is equal to negative 4.9. And then we'll plug in 0.5 squared plus 15 times 0.5 plus 2. So let's figure this out. You might have it. According to BESMAS, the first thing we do is always our exponents. So we're going to deal with 0.5 squared first. So 0.5 squared gives us 0.25. So now we have negative 4.9 times 0.25. We can also do the other one, 15 times 0.5. So we take our 0.5 multiplied by 15, 7.5. Plus 7.5 plus 2. Okay. Next we have negative 4.9. So 4.9 negative times 0.25. Negative 1.225. 0.225 plus 7.5 plus 2. So let's put these all together. We take in our answer, we're adding 7.5 and adding 2, 8.275. 5 would be our height. So our next coordinate is 8.275 in terms of our height. So we did a bit of the work and we figured out what all of the y values are. So essentially, I put brackets around these because each of these is a coordinate. That's what it's told us. So when x is 0, y is 2. So I go on to this, and when x is 0, y is 2. That's my very first point I just figured out. Okay. My second point is at 0.5. So at 0.5, y because again, this is our x and this is our y, is 8.275. So I'm going to have to estimate a little on this because my graph doesn't quite go there. 0.5, that's 8. It's probably about there, okay? And just like that with the estimating, 11, we're going to have to go a little higher. 13, 14. Extend it a little just so we fit everything, right? The next coordinate we have is at 1 and 12.1. So I go down to 1, which is right here on the graph, and I got to go up to 12.1, which is probably about there. So I'm going to put another dot there. Okay. So these ones go up in small increments. Next one is 1.5 and 13.475. So 1.5 is halfway between, and 13, estimated it's about there. Then at the number 2, we're at 12.4, so I go down to 2. You could say that's about 12.4. It's a very thin parabola. 2.5, so it's only a little bit over. 8.875, looking like that. And at the number 3, we're all the way down at 2.9 again. So I'm going to try my best, but we've put all of our dots here. I should have done them in another color. Quickly put them in another color so we can see them a little easier. If we were to connect all these dots, kind of fill in the blanks here, we're going to get something that looks like that. Now, it's not perfectly drawn, but what type of shape is that? Yeah, yeah, and what do they call it? Would it be a linear relationship or quadratic relationship? That's right, this is a parabola. That's how it's also known as. We have a parabola here. So after doing this, we figured out this is a parabola. And we could have told you that, right? Because we knew when we looked at this that it had a squared for the highest variable. So we knew we were going to have a quadratic relationship. But that's the idea. When you do a t-chart, you can figure out how to graph any of them from the equation by plugging in values for x. Now, they plugged in 0, 0.5 because they knew it moved like this. We could have put 1, 2, 3, 4. Any of those are acceptable. Okay? But all you have to do is set up a t-chart like they've done there and kind of fill it out. Okay, so one of the questions was how long it takes to reach its maximum height. We figured out that's at 1.5. The vertex will be its max height, right? And that point was at 1.5 and 13.475. So this is a baseball being hit in the air. So it took 1.5 seconds, and it got to 13.457 meters. Okay, that was the max height. How we could tell this is a parabola, you're right. Our highest variable had the exponent 2. Also, when we graphed it, it made a parabola. Now, the other thing we haven't done, which we could test, is we could do first and second differences, right? Now, we're not going to do it. It's going to take us a little bit. But essentially what should happen is your second differences should be almost exact. They should be almost the exact same numbers. And since they'd all roughly be the same, that means we'd also have a quadratic relationship. Okay? So there's many ways we could test it. Graphing, looking at the equation, or figuring out first and second differences. Okay, so in this question, they want you to compare the graphs they've given you to the original graph, which is y equals x squared. Okay, so we're going to plot that one really quickly. The vertex is where? Do you remember?
Oh, 0. Yeah, negative 3.4.
That's for this one here, where we have y equals x squared minus 3.4. That's right. But what about the original one, when they talk about this guy here?
0 and 0.
Yeah, that's right. His vertex, I guess we'll do him in red so it's a little different. Vertex is there. Then, to draw the next point, what would I do? For this one here. But say I want to draw the entire parabola here. I want to make sure I connect all of my proper points. Do you remember where the next points would be on this?
2 and 2.
Well, if we go over 1, we got to square it, right?
Yeah.
So what's 1 and 1 squared is 1. Yeah. And then if we go back 1 and square it, we go up 1. Right? So remember, we always use this squared when figuring out points in this parabola. So if I were to go over 2, like you said, what would 2 squared be? Yeah. So we go over 2, up how many? Yeah. So there's our point. And when we do it to the left, we go over 2, up. Good. And then what about the next point? Yes, exactly. Good. So it's very important to remember how to do that, because all the parabolas essentially are based off of this one here, okay? When we're talking about comparing them. We're talking about comparing to this specific parabola. So you're right. This one here his shape, his a value was the same. What is the a value? You know what number is technically there?
1.
Yeah. So a is equal to, yeah. And you said it opened up because it was positive, right?
Yeah.
That's good. So opens up. And it was, what happened to it?
It started lower, so
Yeah. So what you would say there is you'd describe it as the vertex. The vertex of the parabola. Yeah. By down negative 3.4. So that's something like this, right? And then we kind of have to estimate the graph, so it's probably roughly like this. This is just a rough sketch. That's exactly it. So our k value is what in this one?
3.4.
Yeah, negative 3.4. So that's enough information there. Opens upward. Now, because a is 1, now you said it was thinner, but actually what it is it's the same. Because technically in this one, it's 1 as well. It's when that number changes to 2, then it becomes thinner. Anything greater than 1. Even 1.1 makes it thin. Or 0.9 makes it wider. That's the idea, okay? So we're looking at a chart here they've given us. Now, looking at the chart, do you think you can tell where the vertex of the chart is? 0 and 5, exactly. So that's very important, okay? So our vertex is at 0 and 5. So our formula for finding an equation is y equals, and this is called vertex form, okay? So we have an A, an H, and a K. Okay? Now because that's the vertex, the all-important part, vertexes are technically, when we go to plug them in, would be, here's our x value and our y value, right? They're actually the same as our h and our k, okay, when we're in this form. So I can replace h and k with exactly the values of my vertex. So let's write them in underneath. The values of this specific vertex are 0 and 5, okay? So we're going to replace in this equation, so we have y equals, I still don't know what a is. X minus what number? Well,
no, x minus 0.
Yeah, that's right. H is 0, so x minus 0 squared plus
5.
Good. Okay. So now I can equate that a little. Y is equal to, still don't know what a is. X minus 0 is just x, right? And this, well, we don't know that yet. Squared plus 5. So we've eliminated the h. The only thing we have left to solve for is the a. Okay? We need to solve for a. Now I can do this because I have many other points along here. Okay? So what we're going to do is we're going to take one of these coordinates and plug it in. And one of these coordinates will help us solve, and it doesn't matter which one we do as long as the parabola is drawn properly. So let's say we'll take the coordinates. I'll take the coordinates 1 and 1 because they're easier. Oh, that is what this is. Don't worry about the rest of this parabola, but this is what we're trying to get at. So what that means is I have an x and a y value, 1 and 1. Okay. So I take a look at my x and my y value, and I'm going to replace them with those exact numbers. You know what? We won't use 1 and 1 just because there's a little. It's very easy. I want to use one that's a little more difficult. Let's use 2 and negative 7. Now I know these numbers don't exactly correspond to a parabola, but the idea is the same. This is how we solve it. Okay. Okay. So let's use 2 and negative 7. We have 2 and negative 7, x and y. So I'm going to replace x with the number 2. Let's actually do that in the other color. So we're going to replace x with 2 and y with negative 7. So now I have negative 7 is equal to
2.
Well, we still don't know what a is, so we got to keep a there. Okay.
And then 2 squared plus 5.
Very good.
And then you want to isolate the a.
Exactly. That's the whole process here. So we're trying to figure out what a is going to be now. Now, when we isolate a variable, well, let's equate this. What is 2 squared going to be?
4.
Okay. 4 times a. What is 4 times a?
4.
Yeah, exactly. So negative 7 is equal to 4a plus 5.
So 9.
Well,
7 equals
well, actually, I can't combine these because this has a variable
And that doesn't.
and this doesn't.
So you want to divide it by itself.
Well, I want to get A by itself. So what I'm going to do is something called like reverse bedmass. Okay. So when we're equating something, we use bedmass. When we're isolating, we use reverse bedmass. So this technically means multiplication, right? We just did multiplication there. So this addition, I want to get the variable all by itself. So I want to move everything else, the numbers on the same side, to the other. So there's only a variable left. So when I move positive 5 to the other side of the equation, what is that going to become?
-5.
Exactly. So we said we move positive 5 over. And this is going to become -7 minus 5 equals 4a. Okay. What is -7 minus 5? I'm going to get a calculator for that one.
12.
So we get -12 equals 4a.
Wouldn't that be +12?
Well, actually, it won't be. We'll get what it is think of it like you're on a number line. If we were on a number line, this is what it's saying. Start at -7. Okay, so we're at
And then
-7.
go down 5.
Exactly, and go down 5. So we would have ended up at -12 too.
Okay.
That's what it's saying.
I was just thinking.
Yeah, that's when they're together, when they're beside each other, the operation.
Okay.
And finally, the last thing we have to do is isolate the a. So that 4 says 4 times a. So in order to move the 4, do you know what we need to do?
Divide it by itself.
So we need to divide both sides by 4. So on the right side, we'll be left with just a.
And on the left is 3.
Well,
-3.
-3. Good. But we're not technically done. We have to put the equation. And really, here was our equation. The only thing we needed to find was a.
So y equals -3.
Y equals -3.
Bracket.
We don't need to have a bracket. We can just leave it like that because we figured out the h. You could say x minus 0 squared, completely fine, but sometimes they want you to simplify. Either are acceptable. So you know what? We'll do bracket x minus 0 squared. Or this would be considered the simpler version, y equals -3 x squared. So that's how you go about solving for the a. Okay, so that's kind of the hard part of what we're doing. So why don't you try that with those two there.